All right. Greetings, fellow grade 10s. It's Mr. Klatrayo here. Now, what I want us to look at today, basically, we are going to be examining what we regard as our trig function, right? So basically, I want us to, go through some of the past papers and see in terms of what can we do to try and solve some trig functions, right? So this basically, it is a past paper of November 2017. Are we together? So now let's see in terms of what does this particular paper have for us. Now, the first one is 5.1. Now, here they say sketch uh, on the grid provided in the answer book the graph of F and the graph of G, right? So they say for 0 degrees, between 0 degrees and 27. So basically, what we are given here, this thing here, it is what we call a restriction, which means firstly, your graph, whenever you are plotting your graph, it's going to range between 0 degrees up until 27 altogether. So, but now what we are going to do, obviously, we are going to draw this in here, right? Now, let's try and draw this firstly here. Now, obviously, we are going to start with our Cartesian plane. So this is going to be our Cartesian plane. And then now, secondly, now we're then going to draw, we're going to have our numbering. Let's number it starting from 1, right? Starting from 1. And then let's say we are having 2. Similarly here, starting from 1. And also, let's say we are having 2. Obviously, this is -1 and 2, and this being our 0, right? So now what is it that you are going to do firstly? Now, if you can understand the graph of f of x firstly, what is it that we are going to do now firstly then? Now, the first important thing that we are going to do, let's start by making a scale, right? So that we can see all our plots or all our points. Let's use a scale of 30, right? So which means we are going to have, let's say this is 30, this is going to be 60, this is going to be 90, then this is going to be our 120, right? 120, this is going to be 150, 180 degrees, and then we are going to have what? We are going to have our 210. I think this is going to be 210 degrees, then 240 degrees, and let's say you're having also our 270 degrees altogether. Now, let's say this is our our Cartesian plane, right? Now, what is it that you are going to do? Obviously, they said the graph ranges between 0 degrees and 270 degrees, right? So that's the reason basically we are having all these plots here, right? Now, the second thing that we are obviously going to do here, we are going to say now, how are we then going to plot the graph? Let's start with the graph of f of sine x subtract 1. Now, ordinarily, the graph of f of sine x, right? If you are having your Cartesian plane, ordinarily the graph of f of sine x, it looks something like this, right? So basically, this is a graph that starts at 0, goes like this, and goes like that, right? Where you are having a turning point there at 90 degrees. 180 degrees, it is an intercept, and 270, it's also a turning point. And then here at your 360 degrees, it's your what? It is your also your intercept altogether. So ordinarily, the graph of sine of x, looks something like this, right? So if you are not sure in terms of what am I referring to, please ensure that you go back and watch the previous video that I did on our trig functions, right? Now, so what will happen basically? Now, this -1, which means the entire graph, it is shifted. How many units? It is shifted 1 unit downward. Okay. So which means all these particular points are going to be shifted 1 unit downward, right? And if all these points are shifted 1 unit downward, what is it that we are going to do now? So we are going to say now, our graph of sine, ordinarily it was going to start like this. It was going to start at 0. It is going to have the turning point at 90 degrees. And then at 180, it was going to have the intercept. And at 270, it was going to have a turning point, right? So now, similarly now, this is going to be also the same thing that happens. But now what will happen basically is all the points will shift 1 unit downward, right? So which means, can you see this graph here? So this graph is going to be shifted. Remember, it started 0, so it's going to start now at -1, right? So which means everything that is happening is still going to happen, but it's going to be shifted 1 unit downward, right? So now let's do it. So which means now here, if you can plot this, the graph is now going to start here at -1, and then it is going to have the turning point again at 90 degrees. But now, because all this point is going to be shifted, let me just draw the original firstly before I draw this one, so that you can see the new transformation. The original graph, basically, it was going to go like this. And remember, I said it has a turning point at 90 degrees. And then now at 108 degrees, it's going to have the intercept. Similarly, now, let's say now, if this graph continue at -270, it is going to have what? It is going to have a turning point, right? At -270 and -1. Please don't forget that at -270 and -1 is going to have that, right? Okay. So this was the original graph of sine of x. But now, because it is shifted 1 unit downward, so this is going to be the impact. Basically, this is the graph that you are required to draw. Now, it will still have all the same impact, but now it is shifted 1 unit downward, which means it still have its turning point here. And then here at 180 degrees, it's going to have this particular shape, right? And then it's going to be it's going to obviously continue at what? To -2, and at -2 it's going to continue and have its turning point out again. So basically, this graph is going to look something like this out again. So this is going to be the new graph of what? The new graph of sine, where it is shifted 1 unit downward, right? But if you're not sure, you can always just go to your calculator and punch this particular graph, then you're going to have it, right? Now let's then move to the second one. So now what is important is this graph that is required of us to draw. It is basically this blue one, right? So which means the graph of sine of x subtract 1 is going to look something like this. And now let's look at the second graph. Now the second graph, it is the second graph of what? Of 2 cos x, right? Now let's start here. The graph of cos x, basically, if let's say you're having f of cos x, the graph of cos x, ordinarily it started at 1, it passes like this, and goes back like this. Basically, where here it's 1, here it's -1, where here it what represent your 90 degrees, where here represent your 108 degrees, where here it represent your 270 degrees, and where this particular point represent your 360 degrees, right? So this is an ordinary graph of cos of x, right? So now these two represent our amplitude, right? So basically, these two now represent our amplitude, which means this graph, what happens to this particular graph, basically, its amplitude, it is stretched to, right? Which means its lowest, remember, amplitude gives us the lowest or the highest point of the graph. How to get? So basically, it is our graph, it's stretches our graph out again. So which means now the same graph that we are having here, you see the same graph that we are having here, it is going to be the same graph, but the only difference is that now it is going to be stretched, right? So which means it's going to start there at -2, and it comes back again like this, right? It goes the same way, but now it's going to go to -2, comes back and intercept here, and go something like this, right? So now let's write it properly though, so that you can see it, right? Out again. So which means the graph is going to now, this one is going to start at 2. So it's going to have the point, a turning point at 2 at 90 degrees. This particular graph is going to have an intercept at -2. At -2 and 108, it's going to have what? It is going to have a turning point. And now at 270 degrees, it's going to have an intercept, right? So which means if you plot this graph, basically it's going to start here, go something like this, It has a turning point here. It comes back here, and it ends here. Out again. So basically, this is going to be the graph of what? This is going to be our graph of cos of 2x altogether, because remember it started at 0 degrees and 270 degrees altogether. Now hopefully this makes sense to you. I tried to simplify this so that you can get this right. Now let's look at the graph of 5.2 or rather 5.2.1. What does 5.2.1 require us to do then now? Now they want us to find out what is the amplitude of G, right? And remember, I said the amplitude, it is the highest or the lowest point of this, right? But now the amplitude, the highest point, it's 2, and the lowest point is -2, right? But because amplitude, we always represent what? We always write the positive, right? Out to get it's always written in positive, so which means the amplitude of this particular graph is only going to be what? It is just going to be 2 out together. So this is going to be the amplitude of ours, which is 2. Now let's look at now the range of f, right? The range of f. Look, someone here is thinking in terms of what is basically your range of this graph of what? The graph of f, right? So they say the range of the graph of your f, right? Now, what is going to be the range of this particular graph of f? Now, let's start here. What is a range, right? Now, basically range, it's all, possible. It's all possible x values, right? All possible, I mean y values, because we are referring to range. And when we are referring to domain, we are saying all possible x values, right? Now they are saying where, in which interval is this graph of f existing. Now, if you can look at the graph of f, it's the blue one, right? And look, now the graph of f, if you can look at all the possible y values, right? Now the y values are this one. Remember this one, this blue, this, right? It represents your y values, right? So now this graph of f, can you see that if you can plot this, right? If you can just move here out together. Remember the graph, it is ending at -2 and 270 here, right? And also if you can continue upward, starting from down, moving upward, the blue graph, can you see that it only have the y values when it ends at what? At 0. It starts at -2 and it ends at what? Your 0. So basically that's where your graph of what? That's where your graph of f, it is having your what? Your negative, or rather your y values out okay. So basically now for this range, you are going to say now, look, this is going to be where your y, it's your element of real numbers, and but your y, it's that what? It ranges, right? Can you see that this point here is included, and also the 0 here, it is included here? Can you see here it's having a 0, right? So which means this particular graph of y, right, it ranges, right? It's going to be greater or equals to, it's going to start at -2 and it ends at what? At 0, right? And these points are also included. That's why we are writing this inclusion sign, because these points are also included, because they are part of the points altogether. It's not like they are approaching these particular points, but they are part of it, because here the graph, it's having a turning point at what? At 0, and basically at 90 degrees and 0 altogether, at 90 degrees and 0. And here it is having a point at what? At your 270 degrees and what? And -2, which means it's going to be the -2 and 0. And can you see that? Because these points, we have these points, so we are going to also write the inclusion sign altogether. So basically that is going to be our range of this particular graph out again. Now then it's going to be that. Now let's see now in terms of this one. Now your 5.3.1. Look, I know some of you are thinking, hey, what is going on here? But simply just look at this. They say the number of solution where f of x is equals to the g of x. Now basically they are saying we want points where the both of these graph touches, right? Touches, right? Where are these graph going to touch or meet or anything like that, right? So basically that's what they want us to do. Now where are these particular graph going to be touching? Now, if you can see, look at the graph of rate. Look at here at 90 degrees. Can you see that both of these graphs are touching? And can you see here, both of these graphs are touching, right? They are touching each other, right? So which means the number of solution where the graph of f of x is equal to the graph of g of x, basically where both graphs are touching, how many solutions are you going to have? This is going to be the first solution, and this is going to be the second solution, right? So which means for 5.3.1, it's going to be how many solutions? It's going to be 2 solutions, right? It's going to be 2 solutions because these particular graphs are going to intersect or touch each other 2 times. How to get? Now that is going to be that. And now, the last question now, this one, they say now the values of x. Now they say using your graph, the values of x in an interval 0 degrees for which this graph of sine of x is equals to 2 plus cos 2x. You see this one now. They are, I know that there are, there are plenty of things that we can do here, but let's see. Now, if you were in this other grade, I was basically going to use the general solution and we are going to solve this simply. But now let's see in terms of what can we do now in here. Now, for us to solve this, they say they want us to use the graph where now we are having the graph of what? For which the what? The graph of, you are having the graph of sine of x, and here you are having the graph of 2, which is equals to 2 plus 2 cos x. How to get? Now, and what is it that you are going to have here? Now, they want a point where both of these graphs are going to meet, right? Now, where are these, both of these points are basically going to meet? Now, let's start here. Now, if you can, ordinarily, let me just come back here. Now, we said, now, if let's say we are having the graph of this, if let's say we are having the graph of sine x, let me just write this, right? If this is your, let's say this is your 90 degrees, this is your 90 degrees, this is your 180 degrees, and this is your 270 degrees, right? The graph of sine of x, just this one, this graph, it is going to look something like this. Is going to start here, have a turning point at 1, let's say this is 2. Let's just write this 1 and 2 so that we can make up our enough space. This, let's say this is 1, -1. This one, it's -2. Then this is 1, then this is 2. Now, this particular graph, it is going to have something like this, have a turning point here, have an intercept, and have a turning point at -1, right? Let's say this is -1. Please don't, let's say this point, it's basically at -1, right? This was going to be the graph of sine of x. Now, the graph of cos of 2 cos x. Now, ordinarily the graph of 2 cos x, remember we've done it here, right? This was the graph of 2x here, where it started here and it ended here. So basically it was just going to be a graph that will start here, it goes and touches here, it moves, it have an intercept here, and it ends here, right? So basically that was going to be the graph of what? Of 2x, of 2x. But now this is what? This is a graph of 2 plus 2x, which means this graph is shifted 2 units upward. And now the original graph, before I come to the one that we are given, the original, the graph of 2 cos x only, it was going to look something like this, right? It was going to start here, have an intercept here. It was then going to continue, have a turning point. Look at this, having a straight line, have a turning point at -2, and comes back, and here it was basically going to look something like this, right? This was going to be this graph. But now they are saying this particular graph now, it is shifted how many units upward? So this graph now, it is shifted how many units upward now? Because there is +2, right? This is +2, which means this graph of 2 cos x, it's now shifted how many units upward? 2 units upward, which means, look, if you are shifting this graph of x 2 units upward, let's see. Now, if let's say you had to stretch this one to make it 3 and 4, this make it 3, this will make it 4, which means firstly, this point you are going to say +2, which means this point here, it was going to be here at what? It was going to be here at your what? It was going to be here at your 4. And then this point here, that is at 0, it is going to be where it is going to be here at 2, right? Because we are shifting this 1, 2, which means this point is going to be here. Let me just erase here. It is going to be here, right? Okay. Now we are saying this particular point that is here, it is going to be shifted 2 units upward also, so it's going to be here. And one thing that I want you to take note, if we move swiftly along here, can you see this 108? Can you see now that if this is -2 and we are saying -2 plus 2, this graph is shifted 2 units upward. So this point here, it is going to also be shifted 2 units upward, which means this is -1 and 2. So it's going to be here at 0, right? And this point here, because this point here, because it was at what, at 0, it is going to be shifted how many units? It is going to be shifted 2 units. Let me just remove this one here. It is going to be shifted 2 units, right? So if this graph is shifted also 2 units here, so this graph is going to this point here, it's going to be here at 2, right? So if, let's say, I had to plot this new graph now, these two graphs that we are having here, so which means they are going to look something like this. It obviously, because this is not in to scale, but it touches here and here, right? And now I want us to look at this graph, the blue graph. Now the blue graph, it is the graph of sine of x. Now the orange like type of graph, it is the graph of 2 plus cos x. Now they want where these graph meet. They want where the graph of sine of x is equals to 2 plus 2 cos x, right? So basically they want where both of these graphs are going to meet. Can you see that these graphs are going to meet here, right? Tell me that you can see that both of these graphs are going to meet here at 108 degrees. And if these graphs are meeting at 108 degrees, so now the value or the values where both of these graphs are going to meet, basically it's going to be where x is equals to what? It is equals to 180 degrees. Okay. So basically that's that. Okay. So now that is going to be where both of our graphs are going to meet, right? Hopefully, look, I tried to simplify this and plot this graph so that you can have an understanding how to get. So basically that's where both of these particular graphs are going to meet, and then you get your 3 marks and then you move. So I think that's as far as this question is concerned. Thank you very much for tuning in. Thank you very much.